Okay, last but not least, part 4, wireless networking. Um, so wireless networking obviously is very important. Demand has increased more and more because we're using these things more and more. Smartphones, tablets, mobile devices. Mobile computing has become the way of the future. Even devices that are stationary like desktops and printers and things like that are going the way of wireless networking because of ease of installation in homes and small offices and everything else. Um, but typically, if you're in an area where walls are already in place and the house is already built, or the building is already in place and everything, walls are already up, it's a lot more difficult to do cabling. Where you might end up deciding that you want to do some kind of hybrid. So you say, I don't want to run cabling to every endpoint, but what I can do is put a wireless NIC in all of these computers and run a few cables to wireless access points. So this is known as a hybrid network, and this is becoming more and more popular. And in fact, you might run a few endpoints for very important devices that need a dedicated line that can never go down. They need the dedicated data line to them. And that would be a good instance for using wired networking. And then you would run wireless networking for, a computer lab where you have a lot of laptops or something to that effect. So you're seeing these hybrid networks more and more and more. So again, in small networks, you're seeing more often than not wireless is what's being utilized. There's a good chance that everybody in class, when you go home, you don't actually connect to your network through a cable. You connect to it through wireless means. So I would wager that nobody in class actually connects to their network through a wire. That would be a pretty safe bet. Some of the benefits is temporary connections to wired networks. So that would be a huge benefit, and that's where hybrids come in. You see this a lot. This is definitely a big benefit for anybody who wants to be able to restrict access to users. So they'd be able to get a temporary connection, but then you could quickly go in, restrict their access, kick them off very, very easily typically. So it's a good backup or contingency plan. If your wired network goes down, you have a wireless option, and a lot of times end devices, PCs, printers, everything else is shipping with a wired option and a wireless option anymore. So my desktop, my printer, they're both wireless and hardwired. They have an option for both, but I use just the wireless end. And if I wanted to, I could run wires to them and have a contingency if they went down. So that's a big factor in using wireless networks as well, or using wireless for your networking. Sometimes you can't reach very far with a wire because of different environmental factors, and you can extend your span beyond what you'd be able to reach with a wire. So. And of course, allowing you to provide customer networks that customers can access, that makes and then keep them separate from the rest of your data. That's a very big benefit that you see a lot more and more. You go to any place of business pretty much, and they have, here's the Wi-Fi code somewhere, or they have an open wireless network that you can access and just either pay a small fee or jump on there by agreeing to whatever terms they have. So. That's very common now. And then roaming. So you're mobile on a wireless network. So if you have a wireless infrastructure that allows for it, you can actually go from one building to the next, and never disconnect from your wireless network. So that's a feature that I implement with a lot of my customers in particular, is mobile networking, so that they can walk from one building to the next and never disconnect from their wireless network. And that's a very handy thing. So here's a typical home wireless network you have. And in fact, this is even less than typical or more than typical, because nowadays the wireless router and cable modem, I mentioned that a wireless router is actually 3 devices in one. It's a switch, it's a router, it's a wireless access point. Nowadays, they're combining them. If you go down to Cable One and say, I want Wi-Fi in my house, they'll put a modem in place that you lease that actually has a wireless router installed as well. So it's really now a four-fold device. It's a switch, it's a router, it's a modem, and it's a wireless access point. So this is a pretty common setup that you see. So a couple of types of wireless networks. You have local area networks, just a wireless or WLAN. This is just for connectivity. In a typical LAN scenario, typically this is done as some kind of hybrid. Then you have an extended LAN. This is where you essentially use wireless connection between interconnecting devices. And this would span out beyond distance limitations. So you would use a point-to-point bridge or some other type of connection to extend out your LAN beyond its normal limitations. Then internet service, you can have what's known as a wireless ISP or a WISP. They provide telecommunications, internet for a network. These are not super common except in more rural areas where they can't get, other types of broadband internet, so DSL or cable. Mobile computing is a final type of wireless. This would refer to the cellular network, and there's a couple of different names for it. An older technology known as WiMAX, and then you have new generations of cellular known as LTE is the latest generation. That stands for something evolution. Can't remember what it is off the top of my head, but it's the latest generation that we're all probably familiar with. You maybe have heard of Verizon 4G LTE, Sprint LTE. Everybody a few years back was so proud of we're full LTE now, but nowadays everybody's LTE, so everybody's using the latest in wireless mobile computing. Now, there are some components required for a wireless network. We've sort of looked at this in the previous chapter, but we're going to reiterate this a little bit. You have to have a wireless NIC. Your wireless NIC is going to have an antenna. Antennas act as a transmitter and receiver. So what it's designed to do, it's kind of dependent on the length of the antenna. Longer antennas are able to do 5 gigahertz wireless signals, and shorter antennas can do 2.4 gigahertz wireless signals. I don't know exactly the specifications of what makes that work, but essentially that antenna is going to go and send it down to the NIC. It's also what is used by access points for transmission and receiving of wireless signals. And then it would internally translate that to Ethernet or whatever other technology you have in your network. So wireless LAN transmission happens in the form of electromagnetic waves in the electromagnetic spectrum. So light is also on this spectrum, so I guess you could say that the medium or the encoding is similar for fiber optic, even though that's not technically true. It's pretty stark difference, but it's still a wave. It's an invisible wave that you can't see, obviously, but typically it's in the form of either radio waves or microwaves, more commonly radio waves. But the frequency is expressed in hertz. Lower frequency transmissions carry less data more slowly over long distance, so 2.4 gigahertz. Higher frequency transmissions, 5 gigahertz, carry more data over shorter distances, faster. So 5 gigahertz is typically a lot less range, but it can carry things a lot faster. But 2.4 goes a lot further and is a lot less affected by interference. So here's some of the following. These are the types that are used for different types of communication. 10 kilohertz to 300 megahertz would fall under radio. So 2.4 gigahertz and 5 gigahertz would fall under microwave, technically. So microwave ovens happen to cook at the same frequency that wireless antennas typically transmit. So just be aware of that. It's not gonna kill you, but it's just something to be aware of. But microwaves are between 300 megahertz and 300 gigahertz, and infrared is 300 gigahertz to 400 terahertz. After infrared, we have the visible spectrum that we can see with our eyes. So it's not far off. I mean, I guess it kind of is pretty far off, but we're well outside of the range of what we can see. But a good way to think about it is invisible electromagnetic waves, where visible light, is what we can see with our eyes. There's also, the primary wireless LAN technologies for transmitting and receiving data are infrared, laser, narrowband, and spread spectrum. The most commonly used one today is going to be spread spectrum. Narrowband was a little bit more common in the case of 802.11a, b, and g, but we use with N and AC, we use spread spectrum. It's able to function a little bit quicker. Infrared essentially uses infrared beams, similar to, I think the best type to point out for this would be remote control. I'm not going to delve into this in too much detail. You can glance at the slide to see the four kinds of infrared LANs, but they're not really super important. We don't go over them too much. Then you have laser-based. Laser-based is what you have. It requires line of sight. It's super tricky to set up. It's not really used in LANs very often, but it does exist. And this would be, what's a good example of this? I don't know if anybody ever had a Tamagotchi. This would have used an infrared laser to send data back and forth. That's the only application I can think of with laser-based, but you had to have a direct connection between the two. Then narrowband. Okay, so narrowband, low-power two-way radio communication. Receiver and transmitter must be tuned to the same frequency to handle incoming data. This is what wireless networks in their early days used. Requires no line of sight. Depending on the frequency, walls or barriers, other interference could interfere with it. So 802.11a, b, and g all use narrowband radio. Okay, and so here's the frequencies for narrowband. But again, the bandwidth is between 1 and 10 megabits per second, highly susceptible to interference, not very expensive, but sort of a thing of the past. It's sort of been phased out. Now we have spread spectrum communication. Spread spectrum allows multiple devices on a wireless network to be transmitting at the same time. So it improves reliability, multiple frequencies are used simultaneously, and it reduces the susceptibility to interference. 802.11n standards and AC standards, which are the modern ones that we use today, both use spread spectrum. So there's two main kinds: frequency hopping and direct sequence modulation. So you can look at that. Don't get too caught up on this stuff, but the bandwidth is actually much higher nowadays. Line of sight to some degree or another, but spread spectrum is a little bit more common in what we use today. So when you're selecting your media, you want to look at those considerations that we talked about at the beginning, but I'm not going to delve into that too much. Here's a little chart that shows you a pretty good comparison of some of the important factors. So the wireless bandwidth, that number has gone up pretty dramatically since this book was last edited, so in 2016. So there's newer technologies that make it much faster. Okay, that's it. So feel free to read the chapter. I'm going to try and have this uploaded by class. It's 4 parts. They're all relatively short this time, so there we go.